we've got an awesome agenda today. We're going to be talking about OpenAI functions released. I guess it was released basically a little bit over a week ago. So very, very recent. Excited to be joined currently by Francisco and Jason, who have been doing a bunch of awesome stuff on in LangChain, on Twitter in general. We will also be joined momentarily by Ati from OpenAI as soon as I invite him to the stage. And I think we'll kick things off. Well, okay, so minor logistics, we are recording. And so it will be accessible on the link here afterwards. And then we'll probably also post it on YouTube afterwards. What we'll basically do is we'll have each of the speakers talk for a few minutes about an overview of what they worked on. So Ati from OpenAI will talk in general about the functions endpoint and kind of set the stage for everything that we'll talk about later. Then we'll have Francisco talk about some of his work that he's been doing. Then we'll go over to Jason, and then we'll finish up with David from ActiveLoop, who I will add to the stage momentarily as well. Then basically what we'll do is we'll go into question and answer. So, there's a lot to discuss. There's a lot to explore. We really want, I think part of the excitement here is it's just so new and there's so many different use cases. So if you do have questions, please put them in the little question box on the right. It's the Q&A box. It's under the chat. It's got the question mark on it. You can also upvote other ones. So basically, after about 30, 40 minutes, we'll just start going through the user questions and answering the top ones. Can be anything about the functions endpoint itself. We're lucky to have someone from OpenAI who can answer that. Can be anything about the use cases that you've seen Jason or Francisco or David tweeting about on Twitter. So yeah, should be a really fun one. So thanks again, everyone, for joining us. Thank you to all the panelists. Panelists sounds really formal, so but thank you guys for joining. And maybe we can kick things off with actually before we do that, maybe quick introductions from everyone just to set the stage for yeah. Francisco, do you want to start?
Yeah, sure. So hi there, my name is Francisco. I am a data scientist. I'm based in Argentina. I worked for several years in a big e-commerce company here in Argentina, like Amazon from Latin America. And I am really, really fascinated with LLMs and the things that are being made possible. I've been building with LLMs and contributing a bit to LangChain as well for the past few months. And recently I've been involved in using functions for tagging and extraction. So that's what I'm playing with right now.
Awesome. Jason, do you want to do a quick intro?
Cool. Yeah. So I'm Jason. I spent the past maybe 8-10 years doing things in machine learning around computer vision and recommendation systems, and I almost neglected natural language processing because I thought it was kind of like a boring subject. And coming back to it, I kind of regret doing that. And now I think language models are sort of like the coolest thing out there. So I remember playing with GPT-2, thinking it was cool, then going back to my actual work, and now GPT-4, I'm kind of like asking nicely, saying please, and doing everything I can to get the answer out. So it's been a fun ride.
All right. Ati, do you want to go?
Sure. Hi, everyone. My name is Ati. I'm an engineer at OpenAI. I helped build chat completions and function calling. And it's crazy to see more than 1,000 people here. So I'm very excited to share more today.
And David.
Hi, everyone. Sorry for running a little bit late. My name is David. I'm the founder of ActiveLoop. Before starting the company, I was doing a PhD at Princeton University. Mostly was in computer vision space, but we had some projects actually building social bots, and super excited for the last 5 years. What happened to the NLP and whole large language model industry, I'll say now. Super excited for this talk and talk about the OpenAI functions.
Awesome. So let's just jump right into it. So Ati, take it away.
Yeah, well, I didn't prepare any slides or anything because I think most of you have sort of played around with the product and built some amazing things and shared them on Twitter. So I'll just give you a little bit of a background and history maybe about how this came to be, where we think this is going, and and why I'm personally excited about all this. Language models sort of came to shore maybe 3-4 years ago. GPT-1, 2, 3 started to show some signs of life last year. And the early use cases were sort of using it for content generation, right? Like write me an email, write me an essay, things like that. And a couple of businesses sort of took off from there. 3.5 came out sort of late last year, early this year. And that's when sort of the more application level integrations really seemed possible. You could actually build natural language interfaces to your products. ChatGPT, of course, is sort of the general purpose interface for natural language. Ask it anything, get it done, get anything done, is sort of the promise of ChatGPT. But what's really exciting about the API and developers building on top of it is that you can bring this power to any other application. 4, of course, is sort of like, way more intelligent, a little bit slow. But the beauty of both 3.5 and 4 is that they were trained on this format called ChatML. And ChatML basically breaks down the language model output, input and output into these like turn-by-turn conversations, where there's a system message that sort of describes instructions to the model, user messages, model messages, and you can imagine adding more roles to this conversation, and that's where this role of sort of functions came out as well. We've always been here at OpenAI interested in tool use as a concept. How do you connect language models safely to the outside world? Whether it's, send me an email or, buy me some food or do my taxes for me. And the early explorations here were very much like, what if we made this one tool? Let's see how well it works. And then what if we made this other tool and how well that works? And the early interface between the language model and these tools was also just plain text. And so the first 2 tools that we built actually are now in production, Code Interpreter and Browsing with Bing. And they're both sort of under the hood, actually just using very simple interfaces to, very similar to all the tools and plugins that you guys might have built using libraries like LangChain. But then as we moved towards plugins earlier this year, and we decided, what if we could generalize this? What if anybody could build with the least effort possible something that plugs into a language model? That's when we came up with the idea of this sort of OpenAPI-based interface. But OpenAPI schemas are like quite verbose and they get very long. And we actually generalized it like, hey, today we might use OpenAPI, but tomorrow we might use GraphQL or some other like, RPC language. You might even want to call tools that are local to the client. Like, I don't know, if you're building an iOS app and at some point you want the language model to decide to take a photo or to vibrate the phone, that stuff doesn't even go over HTTP. And so all of these kind of tool integrations, when generalized, become functions. It's just, call a function and do something with it. And so that's what took us down this path of, JSON schema and generalizing sort of the interface. And we first built plugins and trained the model on it. And early days, it was sort of, showing good life, but not quite there. And in the last 2-3 months since the plugins launch, what we've done is basically repeatedly fine-tune the model on tens of thousands of examples of what good interaction with tools looks like, with the Weather API, with the Wolfram API, and hundreds of other APIs like that. And now the model has been fine-tuned on it and is really good at both choosing when to call a particular tool or plugin or function, pick whatever word you want, using its understanding and reasoning ability, and also then converting that into structured output. The structured output is like 95% there. It mostly outputs valid JSON and mostly outputs the correct output. There are a few more steps we think we can take over the next, coming months to improve that. But it worked for us, and we were like, this has to be unleashed and let the developer creativity flow. So that's sort of what led down to the functions launch. And we're 1 week in, and so many cool demos on Twitter. So that's a quick introduction to how it came to be and where we see things going as well.
That's awesome background, and I'm sure there's a lot of questions around some of that. But one that I have just to set the stage for some of the other stuff that we'll be talking about is a lot of the use cases that I've seen are almost less around function calling and more just like structuring output in a specific way. Like, is that something you guys anticipated? Is that a good use case, or like, it seems a little bit like will the model perform well? Can we expect the model to be like reliable for that use case, basically?
Yeah, it's definitely a supported use case. We definitely encourage people to use function calling for structured output, data extraction, things like that. I understand the interface is kind of like one step removed. Like you wouldn't call it functions, you'd call it, some sort of templating. And there's some cool projects out there like Microsoft Guidance that sort of, show direction on where else templating can go. And so we're definitely looking at those things closely. I think we have some experiments internally on how, stuff like that can work, but as you all know, OpenAI operates at like immense scale, and latency is already a problem, and adding more logic in there can complicate things a little bit. So we're researching ways to do this performantly and safely, and once we have something, we'll share it with the world. Yeah.
Awesome. Awesome. All right, so that's a great overview on the history of functions. And so just going in order, Francisco, do you maybe want to chat a little bit for five-ish minutes or so about what you've been working on and how that relates?
Yeah, sure. So what I've mainly been working on is exactly this, like using the functions functionality to extract information from documents and to tag documents. I'm really excited on how this allows us developers to do this extraction and tagging in a very easy way without any need for training. So starting with tagging is basically extracting from the document a few labels, right? Or setting a few labels for the document. For example, you can ask what the sentiment is for a document, what the language is on a document, or other things, even also for passages or sentences. And I see this like as a zero-shot classification, no need for training, but with the possibility of defining your labels in a very structured way and having the model respect that. And the other great advantage I see is that you can classify into several sets of labels at the same time. So you can have have the sentiment, the language, and for example, the aggressiveness of the comment classified in one code. So I think that is quite great, and having the ability of defining the labels also helps in having some predictability on the output, on the desired output. The other thing is data extraction. So this is also a very common use case where you have unstructured document and you want to extract some entities and their attributes for those entities. So one common example that I've been looking at is like CVs, where you have a lot of CVs and they're all structured differently. Like every CV has its own style and the information is displayed in different places. And also you have some information that is present in some CVs and is not present in others. So you have this challenge. But as Ati was saying, with the new functions functionality, you can. It's kind of like a hack in my view, because you're not actually calling a function after the response from the model, but it's the actual response with those parameters that you care for. So you're telling the model, so here's the function, which is the extract data function, and these are the parameters I need. The parameters I need are, for example, in the CV case, the candidate's name, the candidate skills, the last company that the candidate worked on, and the number of years of experience, for example, and a contact email. So the API will return a function that gives you all these attributes as parameters. And you can, the nice thing about this is you can set for example, the allowed values or the type of the output. And in this way, you can control, you have a great degree of control over what the output looks like. And when you're trying to extract structured data from a structured document, that's exactly what you want. So I think that's really exciting. I've been playing around with it. I think it works really well when rightly prompted and used correctly. So yeah, that's a very nice use case that has been opened with this new release.
And just diving in, when you say rightly prompted, what prompting techniques have you found to work particularly well for functions in particular?
So specifically for extraction, some things I've been doing is, this is nothing new, but I'm asking it not to hallucinate. So do not invent, if you don't find it, do not return it. And also I wrote, if you find no, so if it's not required, right? And if you find no answer, just return an empty string. Like don't be afraid to return an empty string. And that worked well to avoid, trying to place a piece of data just to fit into that value, right, for that attribute. But it's really nothing very sophisticated. It works quite well out of the box.
Awesome. And did you have a demo or anything that you wanted to show for?
Yeah, I can show. So I did just a small demo. This is something I hacked away yesterday. Please, sorry for the design. It's not very beautiful, but it shows like a practical use case of this. So okay, so let's say this is a demo CV, right? The name and what the candidate does, contact, about me, education. So let's say we want to extract structured data from here. This is using also LangChain under the hood, which also uses OpenAI functions. So we can upload here the CV, and here we set a few attributes. This is where we are specifying the type. This is very nice because, for example, there's an example in the LangChain documentation where the written example says Claudia is 1 year older than Alex, or 1 foot higher, I don't remember. And since we set the attribute to a number, it doesn't return 1 year older or 1 foot higher, but it just returns, if Alex was 5, it returns 6, right? And that's because we specified the type we want in the answer. So I really like the fact that we can define what the type is and the model respects that. Another thing we can set is a small description, and this description is very nice. It's kind of like a prompt engineering because we are trying to constrain the model to only give us the type of information that we really want, and not to get confused in giving us a response that we do not care for. So here we're saying, okay, candidate full name, the years of experience. Here is a Boolean, right? If it's a software developer, this is interesting because obviously in the document, it doesn't say I am not a software developer, but it doesn't say that he's a software developer, and it says that his profession is another thing. So it will work correctly. And that's because we specified that it is a Boolean. Again, university, languages, and contact. Here I said ways to contact. This is quite open. It's a text. So this is probably a way to catch many use cases or many strings and not only one, right? So if we submit here, this is running through LangChain. And here is the output. So we get the full name, the years of experience, not a software developer. If there's nothing specified about languages, we get an empty string, university, and all the ways to contact the candidate. So this is a small demo of some way in which this functionality might be useful for people.
Awesome. Thanks for sharing that. All right, Jason, you've been experimenting from the beginning on a lot of pretty out there stuff. So I'm excited to hear what you have to share. And yeah, would love to also hear just a little bit about how your motivation, because you've been doing some of the most interesting stuff on Twitter, I think. And so just love to hear also how you thought about it and started approaching it and stuff like that.
Sure, yeah. I guess I started mostly playing around with this stuff primarily because I've been sort of consulting some early stage startups on figuring out what are the right practices to do. And almost, I would say 90% of the time, it's about having structured data that we can do computations over, right? So agents are kind of too far out, but we still want to do some kind of extraction. I'll give an example of this email segmentation that I've been working on for another company. But ultimately, it's about getting structured data and then running some computation over that data. So this is kind of rough slides, but really it's just code that I've been writing. So I'll go with that. The general idea is that function calls are great. It's structured data, but it's still technically a string. And then we parse it to JSON. And if we use Pydantic, we get basically Python objects right back out, and we don't actually have to write JSON schema. Right? Not only are these strings, they become structured data. And because it's Pydantic, which is a Python object, it also contains computation. In the examples I'll show for like the segment search queries, we see that it's a very flat segmented computation, but I've also shown some examples where we do like kind of a DAG generation that we can then execute in parallel with like DFS or BFS. And then lastly, not only can it be computation, it's computation that could potentially interact with its own inputs. And I'll show an example of doing citations. These are kind of like pretty atrocious abuse of the function call API, but I think these are some cool examples worth showing off. The first example I'll show is one around maybe preventing SQL injection, right? Right now, when we use SQL agents, they kind of just output the SQL with like no escaped values. But we know that to call SQL safely, we want to have template strings and we want to have query parameters. If we model this, so a SQL template has a literal or an identifier. There are parameters that have keys and values with a type. And the SQL query is actually a template and its parameters. And just for safety, I add a is dangerous flag that determines whether or not I think or the model thinks there's any kind of SQL injection. So this is all kind of just modeling the data. What Pydantic can do is it generates the function schema automatically for you. Here, I just give an example of some SQL tables, and then I make a response. And so these are some examples that can give me, right? Give me the ID, give you the name for select true, yada, yada, yada. And then when you look at the examples, it does quite well, right? It escapes the right templates. It uses query parameters. It'll warn me if a query is risky, but still produce a query that is technically safe. So that's a fun example of sort of going away from computation as a string to computation as structured data. In the second example, I want to do something differently. I want to take a request that may contain multiple parts and maybe search across different backends. So again, I have a search type, which is a video or an email. I have a single search object, which is a query and a type. I also implement the execute method, which could potentially run that query. And then I define something called multi-search, which is basically just a list of queries. So in this sense, we can have an array of computation for a single task. And then this execute is just made up, but all it does is it asynchronously calls all these separate tasks. So now, if I have a message that says, send me the video from last week about the investment case study and the documents around GDPR, I can now asynchronously call to two different backends with two different search queries, right? So this is kind of like a flat computation, but we can still go even one step further. Instead of generating almost like a MapReduce query, we can actually generate an arbitrary tree of computations. So this is a crazier example. And so, hopefully this will be uploaded on YouTube. You guys can like go back and forth and pause when it's relevant. But here I have a single question or a multi question where to answer this question, I had to answer like 3 other questions, right? I have a compute, which is let me skip ahead to the query actually. So now we have a query which has an ID, the question it's asking, the ID of its dependencies, and whether it's a single query or a multi-query. And then I have some logic here that says if it's a single query, make the request. If it's a multi-query, query the dependencies first, concatenate all the responses, and then put that in the context of the larger query and try to answer that question. This is just the code that does this kind of work. But again, what this actually gets you is if I scroll to the bottom, if I ask the question, what is the difference between the population of Canada and my home country? It first identifies my home country, finds the population of Canada, finds the population of my home country, which will be answered with the first question, and then finally calculate the difference in populations between Canada and Jason's home country. And you can see all the dependencies are done correctly, which means that if we want to compute over this graph, we can do that in kind of a concurrent way. So this was also like a really fun example because so far it's worked. So that kind of goes over strings with some data, some multiple compute over that data, and then some like dynamic multi-compute over that data. And the last one, which I think is quite interesting, actually is around having the data sort of reference its own inputs. And so here I'm creating an example where I'm trying to find citations to use to answer a question and to make sure that these citations are not hallucinated. So I have a fact class that states a statement, and then also a quote from the context of that statement. So if I want to say that, like, Jason comes from New York, I want to find exactly where I say that. But the substring could be hallucinated. So what I actually do instead is write a regular expression that looks for the substring in the original context and then finds the spans. And what this means is if the spans don't exist, I can kind of convince myself that this data might not actually be real. And then I define a question answer as just a question and a list of facts, which define both the answer and the citations. And again, if you go back down to an example, if the question is, what did I do in college? And this is the context, some code that highlights the data. I can produce statements that answer my question. So the first statement is that I study computational mathematics and physics at the university, in a university. And in the angle brackets, you see exactly the span in the original text that I cite. Same thing here. It says I ran the data science club and was a president for so-and-so. Here, this one statement has 2 citations, right? And again, I get the exact spans of the context, right? These aren't strings that I'm citing now. I'm actually citing the chunk ID, starting from like the character 27th character to the 80th character. This is something I'm actually pretty excited about to explore more. The idea that we can actually propagate citations and make sure that the generations we have are like extremely grounded. These are some of the wild examples I've been going and playing around with these days. Mostly is motivated by some of the consulting work around just making sure things don't lie in production and making sure we can plan tasks and run things in parallel in production. And yeah, I mean, I generally love this idea that we can map data to computation and then back to the data itself. I think once we close that loop, it's going to be pretty exciting. And that's it.
Awesome. Yeah, Jason, those are definitely some of the more wild examples that I've seen.
I would say abusive at this point.
Well, my question is, are there any like more wild ones that you've tried and haven't worked or haven't had time to try yet? Like, what's the most creative kind of like you've gotten with these beyond those?
Let me check my notes real quick. I think one that I really want to try out, which is actually something that Adi called out earlier, which is just turning open JSON, so open API JSON into tools, right? Like I would love to be able to pass in, like Pydantic from api.com/openapi.json and just get all the Pydantic types out. And so you can build this tool that says, like I want to interact with this API. Let me pass in the open API docs. It'll now generate all the types I need, right? So it'll create like every single API call, both the API request as the post request and the request body. And then what this means is now I can basically go from open API to Pydantic schemas, and I can define additional computation against those schemas. That's one of them. The second one is effectively this citation propagation, right? It's often not the case that you answer a question from the ground truth, you have your citations, and you're done. Usually it's a little bit more complicated. Like for example, for large documents, I might want to summarize them first, but the summarizations should have citations. And then if I want to answer questions against those summarizations, I really still want to be citing the original source document. I don't want to be necessarily citing the made up text. And sometimes you might have to, right? If you make some kind of abstractive summary, there is actually no ground truth. But when you have an extractive summary, there is ground truth. And then having to reason about what is like the original thought that the AI had and what was facts that we can pull in from a document. I think building that out would be really incredible. Right? I think an example could be when an agent makes a memory, right? The agent makes a memory cites a text message I sent it. I want to know that its memory of me is correct, but when I reference the memory, it should go back to the text message, not this hallucinated thing, which I am running into sometimes.
Awesome. All right, David, do you want to take it away for the final thing? And then after this, we'll go to questions in the chat. So reminder to drop any questions people have in the Q&A section on the right.
So thanks Harrison for having me. Sorry folks, I have actually prepared a few slides, so hopefully that won't be too much boring, but let me try to share the screen so we can go for it. Is my screen visible? Okay, great.
Yes.
Awesome. So actually one of our community members, he created this FableForge, which is generating picture books actually using OpenAI functions with LangChain, Stable Diffusion, and Deep Lake. And I'm super excited to talk about that. And also we'll do later some slightly more visionary generalizations also happening behind the scenes. So what's FableForge is, it's actually, you can just write a simple prompt and then choose the topic or the style, and it generates a picture book for your kids. A very simple one. But what's happening behind the scenes is very interesting, is that it's actually user prompt is given to a GPT-4 or GPT 3.5 query, which generates a set of prompts with the OpenAI functions. And then these are passed to the image generation process to generate each page of the book. And then this at the end get compiled to a PDF, and then PDF is downloadable. The code is available here, but I'll do a quick brief demo what's happening behind the scenes. So here's like, let's say we want to use FableForge and say, hey, like I want to generate Harry Potter in Tokyo style, Japanese, like this is the style that I'm choosing for in terms of the story pictures. And hey, let me just use GPT-4. So this will take some time to generate the book, given how long it takes the queries, but I already did the preparation before. So here's the kind of the PDF that you can observe that it gets generated. And then the cool thing is that I think that's the biggest difference is instead of just promptly and naively take the data and pass it to some stable diffusion abstract prompts, you can actually use OpenAI functions to try to structure them such that each, like you can construct your own prompts for stable diffusion itself with the OpenAI function as a parameters that gives pass to the prompt chain. So I think that's make it kind of structured query, but this is on the font side of things. It's happening behind the scenes. And I'll show you later as well, like where do we see like how OpenAI functions in LangChain itself is like becomes super critical when you run a bunch of queries. But here's like a very basic like playbook or the book here that gets generated. And then what thing additionally what we allow you to have is it can actually this data gets stored in like Deep Lake, which is a multimodal data lake for deep learning applications. We can actually go and look into the data set, be able to query or use this to train or fine tune any model that you're working on. But let me get back some like the basics, what we have been working on at ActiveLoop for the last 5 years as well. So what we have seen is that similar to how overall AI stack has been fragmented before LangChain days, the data stack itself has been fragmented, and you have folks who have been storing their much of metadata in traditional databases. It could be Snowflake, it could be Postgres. You have a bunch of unstructured data like images, video, audio, tag, like PDFs as well, stored on top of the object storages. And now you have to employ the third set of additional tool, which we call a vector database, to store the indexes of embeddings of the data to be able to run queries on top. And at least from our side, what we have been trying to work on is actually unifying this 3 modules together with the eventually like saying, hey, you actually need a data storage or a memory for all your data, and being it's serverless with compute and storage isolation, letting it to have like multimodality, so you're not only just limited to storing embeddings or text, you can also go with audio and images, video, and lets you to do all-in-one stream and query and visualize the data sets themselves. So if you look from one perspective, how that gets into the whole LangChain and OpenAI ecosystem is that from one side, you can use like that as a vector database to be able to run the queries on top of Deep Lake data sets. But you can also with like OpenAI APIs like for fine tuning, that's tricky, but the rest, like you can actually fine tune your own models on the data that you have collected. But like, let me give you much more like specific example. I will not deep dive on this project that we have been working for the last few months, but I think there's one key thing that's very relevant for today's topic is being able to run search across all the patents. And then what we did is that we looked into all the USPTO documents took them, embedded, actually we split into different structures. You have titles, you have abstracts, you have claims, etc. And you want to be able to run queries on top. But the main difference here is like instead of just running a vector search, you can actually take this and decompose this into both like structured query and also unstructured query. So this will get into the like title search, and the 2007 will get into the filtering function to be able to do that. And what I believe is like OpenAI functions like here is like it makes huge difference as actually structuring your query that you're giving to a database or data storage to be able to have this like separation of what gets into the embedding itself and what gets into the query. And I think at the end is like essentially the way we have been seeing is that the whole market is moving is that you have on top, like think of this as like your like CPUs, like you have L1 cache, L2 cache, L3 cache, and then you have the RAM, and then you have your SSDs or HDD on your computer. Similarly, now we have these like small context foundational models, like think of them up to 8,000 tokens, and then you have slightly like L2 cache, which takes longer to compute, but they can ingest much more bigger data as a context type. And then on the below, you have the data lake concept where you have a bunch of data unstructured stored on somewhere, and then the vector databases. And this is the middle layer that like tools like LangChain help to kind of connect the dots, connect the local computation to the memory itself for the AI to get a large context. And that's what we are super excited about this, that like given the functions themselves that let you have much better connection from the up to the bottom for running. I know this is like this too much theory and everyone wants to get hands-on. So there's another exciting updates coming from us in collaboration with Towards AI and Intel, and also thanks to Harson as well for sharing with the community, is that we launched actually a certification program called GenAI 360, which has a bunch of actually interesting and practical projects that you can learn. And I know LangChain is like super moving fast, and we have been capturing while building this course how things are moving as well. So please feel free to check out learn.activable.ai. It's a LangChain certification course that helps to get started, and with a bunch of actually practical projects that are very cool to see. Thank you very much, everyone. Yeah, happy to answer any questions you might have.
Yeah, so Davi, I think focusing on like the OpenAI functions bit for the demo that you showed when connecting to the stable diffusion kind of like thing. So there, you said you were generating kind of like other parameters for that API. Like what was like the schema of the functions that you were using there?
Let me actually share the schema screen.
Because basically what I'm getting at is this sounds kind of similar to Jason's idea of like hooking up kind of like an API to like a pedantic object or something like that, or just really open, an API to the OpenAI function schema. So I'm wondering kind of like what the process is.
Yeah, I don't think that we use the pedantic specifically, but I think that kind of the way they look, the OpenAI functions were like setting up the type, like what we expect to be returned, what's the description of each property that we're looking for. So you kind of have the structure here, what you are looking to get. Actually, yeah, I didn't mention this, but Jason was super cool demo. I was like, every day I wake up, like I take the phone and then I look a couple of ideas on or like cool projects on the Twitter, and I saw the SQL like injection one and shared with the team as well. So that has been super cool to see. But yeah, so I think the main idea here is that you kind of try to decompose the function into the expectation, what you're looking to get. So if you go into this Ethan's project, where I think he was using in API tools here, so where he builds this kind of the class called BuildBook, and he has been able to like essentially take like you can take the human message here and provide the function as an expected output, and then parse this function to actually a dictionary that gets back to the generating the stable diffusion model. So I think that has been the kind of I'll say the trickiest or interesting connection, that you can use the function itself to generate structured output, and then take the structured output and then give it to the kind of, you have a query plan. I mean, the query plan could be generate images, but you can actually use this in a bunch of other applications.
Cool. All right. So we'll now go to some questions from the audience, and I'll try to select the ones that are most focused on OpenAI functions, just to keep it very focused. I think the top one's a really good one. Seems like the OpenAI functions are the new go-to for anything that requires a structured output. Are there any drawbacks or reasons not to use functions? And so, Ashley, maybe I'll let you take the first stab at this, because I'm assuming, yeah, you guys have some. You guys have been playing around with it for longer than we have, but yeah, like, when should we not use these magical things called functions?
Yeah, great question. I think functions are really great for structured data extraction, for connecting to external tools, APIs, using the model to pick which function to call as well. But that doesn't make existing prompt engineering techniques obsolete. The same models exist, the same prompts still work. And I think the biggest thing here would be one: if you don't need the structure, then don't use it. You'll save a lot of tokens if all you need the model to do is sort of output, a couple of words here or there, or maybe if your existing prompt already works pretty well, or maybe you're using React or one of these other techniques to simulate tool use. Just compare, which one is working better, run your own evaluation. Where are you saving more tokens? And so that's one place where I would say, if it works, if it's not broken, don't fix it. So that's one aspect. And then where else would you not use functions? Yeah, that's the first thing that comes to mind. I'll let anybody else, also answer.
Yeah, I'm curious for Francisco or Jason. Yeah, if you guys have thoughts here.
I guess a part of why I think the function calling works so well is because you have to really over specify your output, right? Like before I could just ask, return true or false, right? The input is like 12 tokens, the output is 1 token. There's some like cost consistency. Now, for me at least, I have like an enum with a description. With every attribute, I have like this list thing, which is a ref thing, then it's in JSON. And you end up having like way more prompt tokens when you ask for that output, right? So I think there is, at least at some level, this like cost consideration of like, okay, at some point, like the prompt tokens actually may add up for simple tasks. Whereas like I might just want to search if true is in my response string rather than parsing this huge object.
Yeah, actually, I was going to ask, how do the tokens work here?
Oh yeah. So what we do is convert the JSON schema into a more compact representation, which is loosely looks like TypeScript. It looks like a TypeScript function that we put into the prompt. And when you say, for example, type string or type number, that literally becomes sort of a TypeScript interface where the key is on the left side and the TypeScript type is on the right side. And we convert the descriptions that you provide into sort of TypeScript comments. And I want to say it's loosely like TypeScript because we don't fully adhere to TypeScript. The model doesn't need perfect TypeScript, right? It is ultimately a reasoning agent based on text. And so that's what we do under the hood. The reason we added this extra layer on top is a couple of reasons. One, it works with existing tools like Pydantic and OpenAI and things like that. Two, as we change the format under the hood, especially with our dynamic models as we train them and retrain them, the underlying format can change. And so we want to give you guys a stable interface to program against. And then the third thing is, JSON schema is actually quite powerful. It allows things like definitions where you can share objects or define something like an address object in one place and then reuse it in multiple other places. And all those neat features are quite nice. So those are the reasons why we opted for this sort of like higher level interface that's more stable and standardized. But under the hood, we sort of change it into a TypeScript-like format, and that does save tokens. We don't dump the JSON schema as is. That would be too verbose. So we try to make it as compact as possible under the hood. Yeah.
Actually, I'm curious, like before that, we had to use these guardrails to do a couple iterations before we can get some structured output from OpenAI calls. Like, what is happening behind the scenes? Like, how do you structure that, like, compared to a neural network? I'm super curious about it.
Yeah, we're not doing any multiple iterations. It's just the fine tune is really good. And so in the very first shot, it basically, in fact, if you see a lot of the function examples, we're not even few shotting, right? We're not showing the model, here are 3 ways, how to get the weather. we just give you the description and it works in the first go. And I think that's the magic of the model is in sort of a zero-shot setting with just a signature, it's able to give you pretty good output. Yeah.
I love to add something to that, which is sometimes when the schema is invalid, reevaluate your own schema. So with the graph example, when I first tried it, I was trying to force it to use like a recursive definition of a node, and it kept giving me dependency arrays of integers instead. And then I realized that the dependency array with integers is actually just a better implementation than having this recursive definition. So I've already gotten to a place where like GPT-4 has pushed back on the code I've written, and I've changed that through basically validation errors. So that was kind of really eye-opening for me.
That's incredible. One thing that actually just came to my mind is we also slashed the pricing for prompt tokens for 3.5 Turbo in this launch for this reason, actually. We discovered some sort of like better caching and operational techniques. So that reduces our costs, and we always want to pass them on to developers. But in this case, as the prompt gets bigger with more context with functions, those cost savings definitely come in pretty clutch. Yeah.
And so you mentioned like this is all done in like a zero-shot manner. Are there any benefits to providing few-shot examples? And if we like, how would we do that if we wanted to? Is that just the same as like I think you have the example flag that is used for traditional chat messages. Would that be the correct way to do that? And do you think that's worth pursuing or yeah?
Yeah, totally. I think you can still few-shot, and it might increase the reliability if you have a particularly complicated case and it's not working. The way I would do it is use the message history. So, put some stuff in the system message and then show the assistant, hey, here's how you would respond, right? In adding an assistant message. And you could, give it a name. You could say, every message in addition to the role and content, you can provide a name as well. You can give it a name like example assistant or something like that. But again, the model knows the role and it has attaches semantic meaning to the role. So the way I would do examples is rather than put them in a system message, show you a few back and forth between the user and the assistant, and now put in the user message. And now you'll get a good assistant message back. Yeah.
Awesome. I saw a few questions in the chat, and the next top one is basically like, React function calls. Like, is there still any value to doing some of the like quote unquote thinking and ask it to think before making a function call? What have people seen there, or is there any? Yeah.
I'll take a quick crack at this, and then if any of you have as well, please jump in. I'm not super, I haven't used React a lot myself. I've played around with it a couple of times. Of course, it's a way to like get the model to like think for itself and then use the tool, but it's also a way to show the thinking to the user. You can actually still do that with functions. In the prompt, if you say, what's the weather like in Boston? And then you say, please describe your thinking first before you call a function, it will do that. And in the response you get back, you get both a content and a function call. This is one of those more advanced features that we really should do a better job documenting. But content and function call are not either or. They can actually both be present. And it'll work with streaming as well. So if you just say, what's the weather like in Boston, please describe your thinking first and only then call a function, or you say, please tell me a joke first and only then call a function, it'll do that. And then give you both content and function callback. Yeah.
I actually had a hard time getting the message content and the function call to return at the same time. I've actually been doing two calls to basically use GPT-4 to think step by step, and then GPT 3.5 to get the function call. But I've definitely found that if you have it do chain of thought, this like complicated graph planning, for example, does, I would say, significantly better.
I see. Yeah, I think if you look back at where this fine tune came from in the plugins use case, you go to ChatGPT, it doesn't do much thinking, right? It sort of jumps into the plugin immediately. And so that's the use case we've been targeting. But I've definitely been hearing great feedback from everyone that like reasoning is really useful to figure out what went wrong, and it also increases quality sometimes. Yeah.
And I guess the last the last question before we wrap up, because we're ending we're ending kind of like the end, is around basically there's a few questions around like reducing kind of like hallucinations basically of these function calls, and you touched on this a bit earlier, Ati, and one of the question even mentions like Microsoft guidance. So I'll maybe break this up into two questions. One, like, what on the OpenAI side are you guys trying to bake into the API to help with that more? And then for Francisco, Jason, and David, like, are there anything that you guys have seen in terms of prompting strategies to help with this in the interim?
Yeah, I think the general problem, you can bake it out into, you want the model to output structured data, and sometimes use its reasoning ability to like also choose what kind of structured data to output, right? That's how you can generalize both the tool use problem and the data extraction problem. Now, our structure is just one of many, right? Like JSON schema that outputs JSON is like one possible structure, but what we want to empower developers to do is sort of you define your structure and sort of mold the model to do what you want it to do. There's a few steps to get there. It's sort of a crawl, walk, run. The crawl stage is what we've just shipped, which is the fine tune. The walk stage is sort of like what we internally call constrained sampling, where essentially, and you've seen this in a few of the open source models as well, where using the logic biases, you can say, hey, if there's a double quotes in a JSON output, the next token must be a comma or something like that. And that just increases the reliability of the output. And you can do that with JSON, you can do that with YAML, some other known formats, right, where the grammar is known. And then sort of the run phase is almost, you define your own grammar. And guidance is sort of an example of that. And you can also use other ways to define grammars, where you define the structure and the model basically 100% reliably outputs structured output and only fills in the gaps where model creativity is required. And it should work with even enums. If you say the enums are A, B, or C, it should 100% guaranteed be only one of those values. And so we're exploring all these approaches. Certainly, there's a lot of like cool stuff that people have done in other places and sharing online. For us, what ends up happening is doing this at scale with good performance and good safety characteristics is the challenge. And so we're definitely excited about all of these things. Like it's top of mind, and we want to ship that. Yeah.
Awesome. I mean, you guys move pretty fast. So like, you say that it's I'm expecting this next week now. So no, I'm just joking. Someone else.
OpenAI is definitely the fastest place I've ever worked at. So don't know. I won't say 1 week, but it'll come soon. Yeah.
Just one comment on extracting structured data. What I found is more than hallucinating is that sometimes some under specification results in an undesired answer. Like for example, if you say candidate name and in the CV example, and you don't add a description, it might confuse and also get the company names or the university name. So like over specifying, it's kind of like the same thing as we have been seeing in prompting, like being really, really explicit about what you want and using the schema to as the place where you can be very clear about what you're expecting in terms of the content, and obviously the typing helps a lot into the steerability of what you actually get out in the JSON. That's my experience. Like I didn't find that it was inventing very, very strange things, but more that if you are not really, really, really clear, it can add extra things that are not what you're actually looking for.
And this kind of gets to Jason's point, where like, I think basically you said when having to write these things out force you to be more descriptive and force you to write better prompts, which seems like a good thing in the long run, anyways.
Yeah, so I think like sorry. No, just was going to say that the names for each of the properties and the descriptions is prompting, at least as I see it. So it's not like prompting is gone. It's just like changed names. So it's still very important to be very clear when one is defining the schema.
Yeah, actually, quick question on that. Oxy, like, are there any guidelines around the schema, like, besides be descriptive? Like, should names be all lowercase? Should they be all uppercase? If yeah, like, any small things or any guidelines there, or just unknown at the moment?
Well, nothing really. I think, like as Francisco was saying, like names are prompts and descriptions are prompts. And that's the thing you should definitely focus your energy on. Yeah. Use good names and use good descriptions. It's almost good habits, right? For your own programming craft. And so that's all I have. Yeah.
Yeah, my recommendation would have been to read the clean code textbook, because like there was an example when I was doing the query merging where I renamed like multi-query merge to just the word merge, and then it completely failed to do the task. So simply just naming a single enum was enough to get the incorrect answer. On top of that, just like asking for the correct answer versus a answer has like embarrassingly worked quite well. Where I was like, don't give me the query plan, give me the correct and complete query plan, and I'll break capital of Jason's home country to what is Jason's home country, what is the capital of that country. So like these small things definitely work. And even with having a good schema, a lot of it is like, if you want to have a function, you don't want to have a function with like 20 variables and 13 Boolean flags that do all this kind of execution, right? You want to just build functions that are good, readable, and turns out if you write good functions for AI, you write good functions for people too.
I think that's a great. Oh,
sorry. Should I add something, or should we close?
Yeah, real quick. We're last thing. Final
Very,
words. I was
very
going to
small.
say that was a great way to end it. If you write good functions for AI, you write good functions for humans.
That's
But
it
this
then.
is going to be even better, Francisco. No, you've got to top it.
So one thing I noticed that is an interesting use case as well is if you want to in one call get several entities with their properties. So say like you want to get all the people that were mentioned with the name and their height, and the dogs that were mentioned with their names and their breed. You can also do that by cleverly prompting or using names and descriptions. So what it will do is, there's an example in the LangChain docs. It will return the person's name and the features with empty dog attributes, right? And then it will return like the dog properties with empty people attributes. So in that way, like with some post processing, you can get 2 entities with all their properties in one call, and that's like an example of what clever prompting can do for you when you're extracting data.
Awesome. All right. Thank you guys for joining. Lots to discuss. I'm sure we could go on. I think the main thing is people probably just need to start experimenting with this, because there's a lot of unknowns and a long tail of use cases. And thank you guys for helping explain and helping guide people along that. Really appreciate it. Have a good one, everyone.
Take care, everyone.
Thanks,
Thank
John.
you.